Hello friends, this video on structure of atom part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 and part 2. So, as I told, right, when you rub this balloon with the towel, it gets charged. So, the scientific community thought from where the charge is coming, right, from how you got the positive charge or negative charge. So, with this thrust in mind to find the reason for the charge, this guy Faraday developed cathode ray tube. Cathode ray tube is a tube which is a vacuum. It has two metals here. One is cathode, one is anode, and they connect to a high voltage and they decrease the pressure here. So if you see, in 1850s only, this guy Faraday, he began to study the electrical discharge of the tubes, and this tube is called cathode ray discharge tubes. This looks exactly like this, and this is glass. Actually, this thing is glass, and there are two metals. They're called electrodes, and they're all sealed in this. And the electrical discharge through the gas can be observed only at low pressure and high voltage. So they pump out everything and they apply very high voltage, and that's why this is called cathode ray tube, where you have low pressure and high voltage. And when high voltage is applied, if you see when they're applying the high voltage, current starts flowing in. Current starts flowing in. Electron starts flowing in from here like this. Current starts flowing in. But you can't see it because you can't see electrons, right? So I'll tell you, they had done something to see the electrons. So if you see, what they had done is they have coated this guy with the fluorescent coating. With this, if electron comes here, it will hit this guy. The moment it hit this guy, it will blink, it will sparkle, and then they can feel that there is something called electron, right? So that's what they have done, and the same thing is used in the television set. If you see the old television set, not the one which we have now, LCD and LED, but the old CRT, cathode ray tube based sets which we had, that had something like this. This is cathode ray, the electron gun. The electron used to come, and this used to hit this phosphorus sheet, you can say, and it used to glow, right? And depending on where it glows, it gives different colors. So, and that's how you see the television. Similar thing here. This is a very basic concept. This is a basic advanced concept, but the concept is all the same, where you have electron hitting the phosphorus and it glows. So with this, he concluded that there is something called electron. Why? Because when it's applying high voltage, something is flowing in and it's touching in, something is getting generated. And what is that thing? That something is having a negative charge for sure. Why? Because it is going from here to here, right? This is positive, and this guy is getting attracted toward positive and getting hit. So that means that something has negative charge for sure. And you can see. So this guy named that the guy is electron. So we'll see that in the next slide. So if you see, when these rays, after passing through anode, they strike this zinc sulfide coating, a bright spot is developed. Correct? So if you see the observation was the cathode rays which you see starts from cathode to anode. So if you see this guy, this was my cathode, this is my anode, right? So this guy started from the negative end, there's a positive end, and this electron keep moving. That was one. The rays are not visible, if you see, but when it strikes the fluorescent metal we have seen, which we have put it here, the phosphorus thing, it glows. That means the ray is not visible, but you can feel that by making sure that that particular ray hits the fluorescent material. In the absence of any electrical magnetic field, they travel in straight lines. That's what he has observed. If he applied electric or magnetic field, the behavior of cathode rays are similar to the expected of negatively charged particles. That's what he has seen. If he has applied some electric field, he has seen that the electron, for example, if he has applied electric field like this, right, and the electron was moving here, but he has seen that electron started moving in this direction. So by applying electric and magnetic field, he saw a change in behavior of the rays. And that change in behavior of the waves was telling loud and clear that this ray is negatively charged. This is negatively charged. by applying by applying electrical and magnetic field, this guy was very sure that the thing which I'm seeing, which is hitting the fluorescent thing and it's an able C, is something which is negative charge, and he called that guy as electron. And this is what we learn. So we'll tell you how it comes also, but this is the place where he discovered electron. Correct. Also, he found that this characteristic of the cathode rays, that is electron now, that doesn't depend on the material of the electrode. You use anything, you use aluminum, copper, it doesn't matter, right? That means he told that the electron's property, the property of electron is independent of which object you choose. That is, I'm telling you, you take a gold, and from gold you take out electron. You take silver, from silver you take out electron. Both electrons will be same. Or you take anything. You take hydrogen, from there you take an electron. All the electron will be same irrespective of which atom you took out. That means electrons are electrons. But in case of atoms, you see atoms are different. The atoms of gold is different from atom of silver, is different from atom of hydrogen. But when you talk about subatomic particle, electron is same. The characteristic of electron is same. It doesn't matter you took out electron from gold, silver, iron, aluminum, doesn't matter. It is same, right? The characteristic of electron is same. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.